Bismillahirrahmanirrahim. Welcome to the second part of this lecture that is speaking about the surface area. We said before that the surface area of given function or just for a given surface over the closed region R is given by S of A, which is equal to the double integral R square root of 1 plus f sub x square plus f sub y square dA. Given that f and its partial derivative with respect to x and y are continuous over a closed region R. And in this part, we're going to give more examples how to find the surface area for some problems. For example, example number 1. Let's find the surface area of that portion of the plane 2x plus 4y plus 4z equal to 12. That is bounded by the coordinate plane in the first octant. The first octant. Okay, so we have this surface, the three-dimensional space. We can find the intercept with the x, y, z, and then we can check the surface that we need to find. For x-intercept, letting y equal to 0, z equal to 0. So I will have 6 for x, 3 for y, and 3 for z. The z is a 3 also. We have something like this shape. Now we need to find the surface area that's bounded by the plane coordinate. So we know that the surface area AS equal to the integral of 1 plus fx square plus f sub y square dA. Now my function will be z equal to f of xy. Write the z variable as a function of x and y. That will be equal to 1 over 4 of 12 minus 2x minus 4y. So this will be my function. Z equal to 1 over 4 multiplied by 12 minus 2x minus 4y. Now for this one, let's find the partial derivatives. f sub x equal to 1 over 4. Derivative with respect to x will give me minus 2. So this is minus 1 half. F sub y equal to 1 over 4 multiplied by minus 4, which is equal to minus 1. So I got the partial derivatives f of x or f sub x and f sub y. This will give me now the surface area R of 1 plus minus 1 half square is 1 over 4 plus f sub y square, that will be 1 dA. Or it is only, that will be square root of 6 divided by 4. So it is 9 over 4, not give me 4. This is 4 plus 1 plus 4 dA over R. I can take it outside as 3 over 2. Square root of 9 is 3 divided by square root of 4 is equal to 2. Now for the region R in the xy plane, I need this to be on the xy plane. So to find the region for or over the xy plane, I will say let z equal to 0. Because it's like we are finding the shadow of the space or of the surface over the xy plane. If we remove the variable x, I will have x and y only. So if we let z equal to 0, we will get 2x plus 4y equal to 0. So this will be my R. 2x plus 4y equal to 0. This is triangle in the xy plane. Where x will be, when y equal to 0, x equal to, sorry, this is not 0, it will be 12. I have 6 and 3. This is 6 and 3. This is R. So the integration will be either use type 1 or type 2. This type 1, I will say dy dx. dy dx means I need to write the variable y as a function of x. From this equation, we have y equal to 12 minus 2x divided by 4. So this line is y equal to, can write it as 1/4 multiplied by 12 minus 2x. And the lower limit is 0. So the limits for the y variables are 0 and 1 over 4 multiplied by 12 minus 2x. For x, start from 0 up to 6. So it is from 0 to 6 for the x, and from 0 to 1 over 4, 12 minus 2x. Now let's integrate. I will have, this is equal to 3 over 2 multiplied by integration of 0 to 6 of y. From 0, the limits from 0 to 1 over 4, 12 minus 2x dx, which is equal to 3 over 2 integration 0 to 6 of 1 over 4 multiplied by 12 minus 2x dx. That will be 3 over 8 multiplied by the integration of 12 minus 2x will be 12x minus x squared from 0 to 6. And this will give me 3 over 8 multiplied by, replace or substitute x by 6 will be 72 minus 36, which give me that will be 3 over 8 multiplied by 36, which is equal to 108 over 8. So the answer is 108 divided by 8 square unit. Square unit. So this is the idea of finding the surface area for some given function above some region R. Let's have another example. Let's find the surface area of that portion of the cylinder x square plus z square equal to 16. That is above the region in the first quadrant bounded on the graphs of x equal to 0, x equal to 2, y equal to 0, and y equal to 5. So what we have now? We have cylinder that is lying horizontally. It is x square and x square plus z square. In the first quadrant, or something like this one. And R is just the rectangle x 0 to x equal to 2, and let's say this is up to y equal to 5. This is y equal to 5, this is x equal to 2, and this is 0, 0. So we're looking for this surface. I need to find the area of this one. Down, this is my region R. So first of all, we have to write the z variable as a function of x and y. We don't have y, we have only x. So z equal to square root of the function is x squared plus z squared equals 16. So it is 16 minus x squared. This is equal to square root of 16 minus x squared. And this will be my function. I can say f of x, y equal to. So f sub x or z sub x is the same. If I say the partial derivative with respect to x will give me minus x divided by square root of 16 minus x squared. Z sub y, there's no y, so the partial derivative with respect to y will be 0. This will give me now the surface area, AS, equal to the double integral over R of 1 plus zx square plus z sub y square, or f sub x, f sub y, dA. Which is equal to integration or double integral of 1 plus x square over 16 minus x square dA. This is equal to, and the common derivative for this one, we'll have this will be 16 minus x square plus x square over 16 minus x square dA, which is equal to this one. I have square root of 16 will be 4 divided by square root of 16 minus x squared dA. And we have R is between 0 to 2 and 0 to 5. It is just a rectangle. This is R. So this will give me the limit for, say, we are going to find for dy dx. Limit for dy is from 0 to 5, dx from 0 to 2. Now I have 4 divided by square root of 16 minus x squared. To integrate this one, I'm going to take 16 as a common factor from the denominator, just to simplify it. I have 4. For the square root, let me take 16 as a common factor. It will be 1 minus x square over 16. That will be 0 to 5, 0 to 2, 4. Square root of 16 is equal to 4. Take it out as 4. I will have 1 minus x divided by 4 to power 2 dx. Is simplified by 4 will cancel this 4. Now I have integration of 1 over square root of 1 minus x over 4 to power 2. This is equal to sine inverse. Integration of 1 over square root of 1 minus x over 2 square or over 4 square equal to sine inverse of x over 4. So this is equal to sine inverse. Okay, since we are just, I'm sorry, we integrated with respect to y first. So this will be considered as constant. It is 1 over 1 minus x over 4 to power 2 multiplied by y from 0 to 5 dx. But we integrated with respect to y first. We use type 1, which is equal to y from 0 to 5 is equal to 5. I will take it outside as a constant. So I will get 5 multiplied by integration 0 to 2 of the integration 1 over 1 minus x over 4 to power 2 dx. This will give me sine inverse of x over 4, limit from 0 to 2. So it is equal to 5 multiplied by sine inverse x over 4 from 0 to 2. Multiplied by 4. This is by substitution. Using the u substitution, take u equal to x over 4, then du will be 1 over 4 dx, or dx equal to 4 du. You can do this by integration by substitution to convert it to standard formula of the sine inverse. That is 5 multiplied by 4 sine inverse x over 4, and the limit between 0 to 2. That will give me 20 multiplied by, replace x by 2, it is sine inverse of 2 over 4, which is 1/2 minus sine inverse of 0. This is 0. And this is pi over 6. That will be 20 pi over 6 or 10 pi over 3. Squared unit. This is how to find the surface area for some given function over some closed region R.